So today I want to discuss the second question from day 7. So what the question is, copy list with random pointer. So what is the basic thing we have to do in the question? We are given a linked list, but we are also given, apart from the next pointer, we are also given a additional additional pointer that points to any node in the linked list. Okay, and what we have to do, we have to deep copy this given linked list and return it. Basic, this we have to do. We have to deep copy this old node in old linked list, and we have to create a new linked list such that in which there are new nodes, and the random pointer of these new nodes point to the nodes that are newly formed in that linked list. Okay, so we just read the question. We are given the linked list of length n such that each node contain an additional random pointer, okay, which could points to any node in the linked list or null. Construct a deep copy of the linked list. The deep copy should consist of n brand new nodes where each new node has its value uh, set to the value of its corresponding original node. Both the next and the random pointer of the new nodes should point to the new nodes in the copied list such that the pointer in the original list and the copied list represent the same state. Okay, so this is the basic scenario. We have to create a linked list that is basically the deep copy of the linked list, and none of the link will be set up between the old linked list and the new linked list. So we have to just deep copy it. Everything, every memory allocation, every link that will be set up is between the new linked list. Nothing will be set up in between the new linked list and the old linked list. So how will we do it? So how will we try to approach this question? So basically this is a sample test case. So in this test case, the nodes, we have the nodes, and this red arrow represents a link that is set up by the random pointer. Okay, so the red is the link set up by the random pointer. Okay, the value pointed by the random pointer, and white is just the next pointer of the normal single linked list. Okay, so what we are trying to do, we are trying to do the deep copy. Okay, but just we are doing one thing, we are allocating new space for this one. So this is the old linked list. We are just trying to copy this linked list, but the memory allocation for the new linked list will be different from this old linked list. There should not be any link between the old linked list and the new linked list. Okay. First thing what we'll do, let us suppose if there were no random pointer. Let us suppose for a second, let us suppose there are no random pointer. Random pointer होते ही नहीं. So it would be a easy task for us to clone a single linked list. It would be a simple single linked list. So we can easily clone it. We just create its deep copy. We can allocate memory for the nodes dynamically, and we iterate over the old linked list, and we copy the value from the old linked list in our new linked list. Okay, so but due to the presence of the random pointer, this question become a little bit difficult. Okay, little bit, but we'll try to solve it and explain it more precisely. Okay, so what we'll do, a simple easy task. First thing, we'll create a simple single linked list for the given linked list. Given old linked list we'll create without any random pointer, without caring about the random pointer. We just create our new linked list that just has the random pointer and the value corresponding to that of the original linked list. Okay. So for each of these nodes, the random pointer would be pointing to null. Okay. For each of these nodes, the random pointer would be pointing to null. Now we are going to do, what we are going to do, how would we set up a link between, because how would we set up a link between this, the new 13 node and that of 7th, between these node, how would we set up a node? So what we'll do, we'll maintain a hash map. Second thing, we will maintain a hash map. So why we are using a hash map? Because we are trying to store the address of the nodes that has the same values, that correspond to the same value. That means in the old linked list, let's suppose this node has address 100, this 200, 400, 800, 1600. Let us suppose this has 3200, 6400, 120, 500, 700. Let us suppose these are addresses of these particular nodes. So what we are trying to do, we are trying to map the corresponding nodes in the linked list. So this node correspond to this node correspond to this node correspond to this node, because these are basically just the clone of this linked list is just a clone of the old linked list. So so these nodes are associated with each other. So we are going to store the key value pair as an address of the nodes in the old linked list and in the new linked list. So in the old linked list, the address of this node 7 is 100. In the new linked list, the address of 7 node is 2, 300, 2000. The address of 13, 13 node is 200. In new linked list, it is 6400. So we'll maintain a linked list for each value of the node. So 120, 800, that is the address of the node 10. It's correspond to 500 in the new linked list, and this correspond to the node 1 correspond to 700. This we have taken into count. So now what we'll do, we'll traverse our original linked list, this one. We're going to traverse our original linked list. Let's suppose our current pointer is pointing to this one. Okay, current pointer is pointing to this one. We're gonna check at which position, sorry, at which our random pointer is pointing. Okay, at which node our random pointer is pointing. So at the first node, at the current node, the node is 7 and it is pointing to null. So for this, the value remains null. Okay, now our current, we just iterate over the given old array. We are at node 13. So we will take into count the value corresponding to node 13 in the new linked list. So this is, let's suppose this is the copy node. Okay, this is just the copy of this current node, but it has new memory address. But we can get the memory address of this node using the hash map. So for this node, what we'll do, we'll take into count the hash map, and we'll get the address of this node, and it will be pointed by the copy node. And for this current node, its random pointer is pointing to node 7. So what we'll do, we'll make the copy node random pointer points to the value pointed by the current pointer, current pointer random. So this are current pointer. This is corresponding to 13 node, and 13 node has its random pointer pointing to 7. And we look for the value, we look for the node 7 in the new linked list, and we'll set up a link between them. So the copy node, that is this one's random pointer would be pointing to the current node's random is 7, and the value corresponding to 7, that is the 100 corresponding to 3200. So this one will be pointing to this one. Okay, now again now again we'll move to this node. It would be much clear when we traverse the whole linked list. Okay, for this node we'll look for the corresponding value in the new linked list. So our copy node will be this. Okay, our copy node will be this. Now in the original linked list, there the node 11 has its random pointer pointing to node 1. And what we'll do, we'll make our random pointer of copy node points to the value of node 1 corresponding to new linked list. So there will be a link between this and this, because of the hash map we can get the value of the node 1 in the new linked list. Now again we'll move to the next node. Now again there is a link between 10 and between our random pointer of the node 10 is pointing to 11. So our copy node will become this, and copy node's random pointer would be pointing to the value corresponding to 11 in the new linked list, that is this one. Okay, the same case goes for the next node, that is the last node. It has its random pointer pointing to 7. So we'll look for the corresponding value in the new linked list. So this is our new copy node, and its random would be pointing to the node 7 in the new linked list, and its value can be get easily from the hash map. So this is how it's look too messy, but now when we look at the code, it would be too easy for you to understand how we are doing the thing. And from the approach, you can easily get, we are just doing simple thing. We are just creating a singly linked list from the given linked list, simple singly linked list we are creating from the given linked list without any care of the random pointer. Now what we'll do, we'll store in the hash map the value of the original node, the address of the original node, okay, and the value address of the copy node. Okay, this is what we are going to do, and we'll iterate over the original node, maintaining a pointer. We'll maintain a pointer to traverse the linked list, and for every node what we are doing, we are looking for its corresponding copy node value in the hash map. And for the random pointer we are doing the same thing, and for the random pointer, the value pointed by the random pointer, that is the node pointed by the random pointer, its value, its corresponding copy node is, its address is also stored in the hash map. So we can look for the node value pointed by the random pointer of the current linked list in the hash map. So this approach requires a time complexity of order of n, because we are traversing the array, and space complexity is of hash map order of n, because we are storing the address of every node. Okay, now we'll look at the code. So now we'll look at the code. So what we have a function named copy random list that returns a node pointer. Okay, it has received the head pointer as a parameter. So we are checking for the edge condition. If there is no node in the linked list, then what we'll copy nothing, will return none. Then what we are doing, we are maintaining a temporary pointer that initially stored the head of the linked list, the head of the linked list, and head 2 is basically the head of the copy linked list, that is the clone linked list. Okay, and temp2 is the pointer that is we take into account and take into account for the new linked list. It will be used to traverse the new linked list. Okay, we are maintaining, as we have said, an hash map. So what we are doing, we are traversing over our old linked list and forming a new linked list, and correspondingly we are storing the value of the in the hash map of the original node and the copy node, original node corresponding to its copy node. Okay, this is what we are doing, and traversing the array, traversing the linked list, sorry. So we have to traverse the linked list one more time because we have to set up the random link. Okay, so we make a temporary pointer points to the head of the original linked list, and we'll traverse the original linked list till our pointer would point to null. We are getting the copy node corresponding to the original node, and we are checking if the value pointed by the random pointer is null. We are going to make the random pointer of the copy node points to null. Else what we are going to do, we are checking for the node we are checking for the node pointed by the temporary pointer in the original linked list, and correspondingly we are checking for its copy node in the new linked list. Okay, and we are storing it in the copy nodes random, that is the current nodes random. Okay, and we are iterating over the original linked list. Okay, at the end what we're going to do, we're going to return the head of the new linked list. So this is the question, that is the second question from Stylus SDC. If you have any doubt, please feel free to ask in the comments. Okay, bye.